right, dropping. Whoa.
All right, I'm sure you have a bunch of questions, like how fast do they go? Can you go uphill? And for you snowboarders, can you pull someone along the flats? Well, don't worry, we're gonna get to all of that in a second, but let's start out with something simple. Why jet skis? To be completely honest, I always hated that these were called jet skis. They're clearly supposed to be called motorcycles. In all seriousness, it's to go fast. My parents heard about this project and I told them it was to get to untouched snow, and sure, that part's great too, but it's to go fast. All right, now that we know why jet skis, let's talk about how jet skis. And for that, let's go to the workshop, because there's two main problems we need to solve.
And those two things are jets and skis. So let's start with the jets. This is a jet engine that I made a little over 10 years ago. This is to say that I've had some experience with combustion jet engines in the past. I even put this on a rental scooter. Now, this jet engine has a few problems that make it not great for jet skis. The obvious one is it's really heavy. Besides that, it has a bunch of extra components that are needed to make it work. Fuel regulators, oil systems, stuff like that. It's also really loud and makes a bunch of smoke. Oh, and the exhaust gas temperature is over 1,500 degrees Fahrenheit, which is a pretty big burn hazard for both me and anyone that happens to be behind me. So what are we gonna do? We're gonna use EDFs. These are basically what RC airplane enthusiasts use when they want to replicate a jet engine on an RC aircraft. Now I know what you're thinking. There's no way a little electric motor can outperform an actual jet engine, right? And you'd be right in the past. Thanks to advancements in battery technology, these things are insane. This guy right here pulls over 7.5 kilowatts of power. To put a more meaningful number to that, that's 20 pounds of thrust. This whole jet engine right here only makes about 15 pounds of thrust. This is light enough that you can throw it up in the air and catch it. I would not try that with this. If we compare those micro turbines with one of these EDFs, you'll find that most of them actually make less than 20 pounds of thrust. And if we look at one that makes a little bit more than this, well, it only makes about 30 pounds of thrust, and it costs thousands of dollars, where this only costs hundreds of dollars. Seeing as we need two of them because jet skis, plural, the EDFs are a no-brainer. So we got our jet engine figured out. Now it's time to move on to the second thing, our skis. First I was thinking, yeah, you just take the EDF, you mount it onto the ski, ta-da, jet skis. But there's a big problem with that. See, if we were to just mount the EDF to the ski, that's only an inch or so from the ground, which means everything we're kicking up as we're skiing is gonna go right into this. That is how you end up with a second exploded one. And no, that's not what happened to this. That was much stupider. But there's a second problem too, one that's a little bit less obvious. See, skiing is really difficult, and it took me a few seasons to learn how to do the skiing thing. For those of you that haven't skied, I'll throw in some footage. Basically, there's all of these little micro movements that you have to do while you're skiing to control your speed, control where you're trying to go. You don't just point your tips down the slope and pizza or French fry, despite South Park making it seem that way.
Pizza, French fries, pizza, French fries.
If we just take our EDF and mount it to the ski, the thrust from that EDF is going to be pushing us in whatever direction our skis are facing, which means when we're doing those little micro movements, our thrust is not going to be downhill in the expected direction. I just don't think it would work that well. What if instead we take the EDF and we mount it under my arm in some kind of way? That way, as I'm skiing, my legs can just do the skiing thing, and my arms are where the thrust is, which means I can point my arms to kind of vector the thrust. I guess instead of jet skis, that means I'm doing arm EDFs, but I want it to be functional, not me just crashing into trees. Although, I guess that would also kind of be humorous, wouldn't it? Okay, let's build this thing. This is extruded aluminum. This specific profile is 4040, but for this project, probably gonna use 3030. No worries, I'll just hit this with shrink ray.
All right, now that we got our metal shrunk, we can just put it up here for safekeeping. And then let's talk about the other stuff that we need.
Basically what I'm thinking is using this as the main frame of the project. I can have that underneath my arm, have some kind of bracket that mounts it to my arm, and then this can be the thing that everything attaches to. Obviously, we're gonna need to attach our EDF to the extruded aluminum. We need some kind of control scheme. I'm thinking a Wii nunchuck. We're gonna need a microcontroller to interpret the commands from the nunchuck, and then send that to an ESC that powers this motor. Also, these run at 58 volts. Microcontrollers don't like 58 volts. So we're also gonna need some voltage regulation stuff to make the microcontroller happy and not explode. Now, the Wii nunchuck makes a lot of sense. It has a multi-billion-dollar company that has already figured out ergonomics, and it also has a built-in gyroscope, which means we can do stuff like adding in fall detection. I also took a long time to film this project. When I designed the control scheme, it was like 2 years ago, right after the Titan submersible imploded, and I just thought using a video game controller would be kind of funny. A knockoff video game controller at that. There's no way I'm spending money on a real Wii nunchuck. I'm gonna get this like $5 one on Amazon instead. Speaking of taking way too long to film a project, when I started this, I was thinking I was just gonna 3D print a bracket and attach this to this. This was right around OpenSauce 1. And I got to talk to James from the Hacksmith. Yes, the Hacksmith himself. I told him about this project, and he asked me, without me bringing it up, do you plan on attaching the EDF to your body with a 3D print? To which I said yes, and he replied, don't. Didn't go into much detail, but it was self-explanatory. Him being the Hacksmith, he knows what he's talking about, but I thought I would test out a print myself. Let's see. Was he right? Probably right. Couldn't find my hammer, so I got a mallet. So, new design constraint, I'm saying that the connection between the EDF and my body needs to be metal all the way through. So we're gonna make it out of aluminum. How are we gonna do that? I did what any sane person would do, and I bought myself a mill. It's a little torn apart right now. I'm working on it, tuning it up, making it just a little bit more accurate for the next project. But let's travel back in time to when I first got this and tell past me to turn his camera on, start recording, and don't say anything so I can do a bunch of voiceover. Yeah, seems like the right move.
All right, here goes nothing. Hey, I think we did it. I'm in voiceover now. I guess it's time for a milling montage. So while my mill's doing its thing, let's go over what we're trying to make. In CAD, I got the EDF in red, and the bracket that we need to make is this blue part here. It consists of 5 pieces, and they just bolt together afterwards. This lets me make a more complex 3D shape out of a bunch of cheap plate stock instead of having to remove all of the material from a big block. Now, these aren't the most machinable parts. There's a lot of angles that make clamping them in a vise hard, but I figured I'd make it look cool in CAD and figure out how to do the machining in the future, which is now. Any issues I run into with doing something a certain way is just a learning opportunity, so I don't make the same mistake on a future project. At least, that's what I told myself. With our first operation done, we can go ahead and give it a quick rinse in the sink, cut the tabs, clean it up, and then move on to milling the next part. If you don't have one of those vibrating oscillating tools, pick one up. It's quickly becoming one of my favorite workshop tools. Going back to CAD, you can see this red intake ring that's on the front of the EDF now. The manufacturer claims that adding that ring adds 40% thrust, which I was pretty dubious about, but let me tell you, in real life, it's totally noticeable. It also makes the EDF a lot quieter, which I guess makes sense. It's the same energy going into the EDF. Now it's less loud, so the energy going into the sound now is going into thrust. Great. Don't get me wrong, it still sounds like a jet engine, and it's still pretty loud, but at least your ears aren't ringing when you're done using it. Let's focus on the intake ring. It needed some way of attaching to the EDF, and I didn't want to glue it directly onto it because I figured if something was to break, it would probably be the intake ring, which was wrong, but I was thinking ahead. So instead I made this gray cowling, again just trying to make it look cool. It bolts onto the EDF and the metal frame to keep everything aligned, and the intake ring can just mount onto that instead. This part's not structural, so it's just 3D printed. With the CAD done, let's move back to our milling. This is probably the most annoying part that I had to make. You can't drill onto a sloped surface, so I had to make this little pocket before drilling, and getting the right sized end mill was a challenge. I used the wrong one, but it worked in the end. With a quick wash up, we can see all of our parts are nicely made, and we can get on to our final cleanup, assembly, and then putting them in a box to store for 2 years so I can open it up in the future, or the present. I'm doing the voiceover in the future present. Whatever.
yeah, put it in a box and we can move on with our project.
Doesn't even go up all the way. Whatever, we'll make it work in editing. Oh, yeah, of course. Time travel. Huh, even came pre-assembled. Nice. So we have our bracket and we have our piece of metal, but before I go and attach it, there's one more thing that I want to do to this. I'll explain as I go, but let's head over to the vise. I want to tap this piece of metal to accept this eye bolt, and there's two reasons for that. The first goes back to the project being attached to my body with metal all the way through. By putting this eye bolt here, I can use a carabiner and attach this to a climbing harness. There's a second reason too. By having the eye bolt attached to a climbing harness, I can have the thrust go into my hips. So instead of having to hold back 40 pounds with just my arms for the entire time I'm using the project, it's just going to be pulling my body along. I also went with a long eye bolt, so that way if I ever need to move this to be a bit further from my body, I can just loosen it up a little, add a jam nut behind it, lock it down, and that way I get a little bit of adjustability.
With that done, we can go ahead and attach our metal EDF bracket to our extruded aluminum.
How am I going to attach this to my arm? I spent a lot of time trying to think of different solutions, and maybe there's something better out there. If you can think of anything, let me know. What I found is a range of motion brace, or ROM brace. These are used for physical therapy when you need to limit the mobility of a limb. Normally there'd be like another section of this that forms an L on your arm and you can dial in the range of motion that you'd want. I thought that having the upper section might actually be beneficial, but when I actually went to use the thing, it was just really annoying having to undo Velcro at the top of my arm to get my arm in and out. Like I said, I don't think it's the optimal solution. You're paying for a mechanism that you ultimately destroy. The next question is, how do we attach our brace to our EDF mount?
I'm thinking of making some kind of L bracket out of some aluminum.
Seriously, it hits the handle. Who designed this? Vivor, come on.
Next, we clean up our parts so we don't cut ourselves and we can get to bending. This is a vise press brake, and it is a great tool when you use it correctly, which I did not do. But yeah, I got impatient, I decided to use a cheater bar on my vise, and well, you can guess what happened next.
Hey, it almost got to 90 degrees. Almost.
I was annoyed at myself for all of like 5 seconds, but then I remembered I kind of hated this rotation mechanism, so new vise ordered, we can move on. Yeah, just doing what I did before I had a vise, drilling onto a cutting board, just clamped to the workbench.
With a broken vise, but one good part, we can proceed. Let me zoom in and I'll show you tightening some nuts and bolts. I swear these videos are just gonna be me descending further into madness. Is my camera not even focused? Camera! Is tightening nuts and bolts thrilling YouTube? Put it on upside down.
And then to top it all off, my microphone died. So I decided to call it a night, import the footage I had, only to find out that my DaVinci Resolve project also corrupted. Not gonna subject you to that side quest. Moving on.
Oh boy, so we're back. I have the thing disassembled and we're gonna do it all over again. My favorite thing to do.
I realized in editing I didn't show attaching the EDF, so here's me voicing over some dead microphone footage. Self-explanatory, but yeah, here you go.
With our EDF mounted, we need to somehow power it, and we can't just take our battery voltage and jam the DC from it in here. Simply won't work, which means we need an ESC. Oh boy, do RC airplane people love 3-letter acronyms. Anyway, we need some way of mounting our ESC, and to do that, I made a metal bracket here. 3D printed one probably would work, but I have a mill. You know, when you have a hammer, everything looks like a nail. I whacked it onto this bracket just with some rivets. Rivets are cool. I filmed a video of me riveting a rivet with a rivet gun, but my mic wasn't working, so here's me doing rivet sound effects. Oh man, this is hard to squeeze. Click. Riveting done. How riveting. Moving on. Our ESC mounts really simply. There's some bolt holes that are already on it. And then I have some little 3D printed standoffs. The standoffs serve one main purpose. It's so I can jam all the wires underneath it and then tighten the bolts down so they don't fly everywhere. That's about it. We need some way of controlling this. And ideally a handle to hold on to, because right now it kind of flaps around a bit. As I alluded to earlier, the way that we're controlling this is with a Wii nunchuck. So I basically took a block of clay, I stuck it on the table, squeezed it with my hand, and then I 3D scanned it to get the grip here. Yeah, get yourself a 3D scanner and you'll use it like once or twice a year. But when you use it, it's because nothing else can do the job. Maybe affiliate link down below, I don't know. I am a fan of my Einstar scanner. I bought the one that I used for this project with my own money. They have sent me one, but the only reason I took the one they sent me is because I like the one that I bought myself so much. That said, they didn't let me keep the nice one that they sent me, so. I don't know, channel's not big enough for me to be able to keep my fun toys that I get. Like, comment, share, subscribe, all that stuff. So I can keep a 3D scanner. All right, obviously we are missing the intake ring. That goes on just like so. That gets glued on afterwards. We got all of this mounted and pretty much ready to go. The only thing left is some way to convert the throttle signal from the Wii nunchuck to something that the ESC can understand. The ESC talks PWM and the Wii nunchuck talks a different language called I2C. Luckily, there's libraries that handle both of those, so all we need is a microcontroller and a little bit of code, which I'm pausing to show you. You are reading the code, right? I swear, coding is cool. The code's really simple. It looks for two things: the trigger being pulled down, that acts as a safety, and then the joystick. Joystick in the middle, no throttle. Joystick all the way up, maximum throttle. The battery for this is 58 volts, and the microcontroller expects 3.3 volts. The microcontroller expects 5 volts. So to do that, we just get ourselves a voltage regulator, and we stick it somewhere on the metal where it's out of the way. Lastly, our microcontroller gets a little box so it can also attach to the metal. Easy. Only thing left to do is talk about the battery, and then we can take this to the mountain and have some fun. So, battery time. Real quick before battery time. Talking about our voltage regulator, I'm pretty sure that the voltage regulator is what caused my EDF to explode. Ask yourself, how could a voltage regulator cause an EDF to explode? I'll answer it in a bit. All right, battery time! What makes this battery so special? Well, I'm glad you asked, because batteries are really interesting. What does make a battery interesting? This is a 58 volt battery, and it can output 250 amps, but that is limited by the BMS down here. With the BMS, this battery can continuously output more power than the main circuit breaker in most apartment complexes. The way it's constructed is with 18650s, lithium-ion cells. The topology of the battery is a 14S14P, which means that there are blocks of 14 batteries all in parallel, and then 14 of those blocks are chained in series in a big U shape. More batteries in parallel means more amperage, more batteries in series means higher voltage. So this has both of those. All of the stuff here is actually pretty simple, even though it kind of looks like I glued a graphics card to a bomb. This is the BMS. This is in charge of charging and discharging the battery. We have a balancer. So this just shuffles charge between all those blocks to make sure that everything's equal. Then we have the main switch right here. And then just in case the BMS fails, I have a backup 300 amp slow blow fuse that will hopefully cut power if anything goes catastrophically wrong before something goes catastrophically wrong. Funny enough, all of the times I've been on the mountain, Ski Patrol has asked if I have jet fuel in my backpack, and as soon as I tell them, oh, it's battery powered, they don't seem to care. Yeah, to be honest, if I had to decide between jet fuel lighting on fire or this lighting on fire, I'd probably choose the jet fuel. Anyway, it's time to pack all this stuff up, strap on our jet skis, and head to the mountain. Shouldn't you be doing all this when you actually get to the mountain? Yeah, but I forgot to film it, so I'm doing it now. Yeah, fair enough. Okay. They're jet skis, but for snow. like jet skis. Next, let's answer the question I get asked the most. Can these get you uphill? Well, for me, they do a pretty decent job. Getting a bit of a running start, well, not really running, but boosting on the flats with the EDFs, I get most of the way up. I just have to do a little bit of a ski walk at the top where it gets a bit steeper.
Now I gotta boot up this myself.
On the second try, I tried from a dead stop, and while I still had to do a ski walk, the thrust makes me pretty much weightless, so it's way easier for me to get uphill than the people on the left that are basically having to turn sideways. Later on, I'm going to swap out with my cameraman. He's 40 pounds lighter and he goes a lot faster, so stay tuned to see if he can make it up this hill. So, going uphill is one thing, but a much more common problem you run into on the slopes is getting stuck on flat spots. So, how do the jet skis deal with that? Well, they do incredibly well. See, it's not an instant acceleration, but instead a slow buildup that just keeps making you go faster and faster and faster, which means that on the flats, you can even tow someone behind you. And this is like properly on the flats. There's no slope here. People are walking. Yet, this thing gets you moving fast. Obviously, this draws a crowd, so everyone wants to see how strong it is. Do you want to feel how strong it is? Here, stand behind me real quick. Yeah, well, let me get the jacket zipped up. I don't want to shred my jacket. Shredded 2 shirts, making it and like testing it and everything. Ready? All right.
So how does it propel you?
Pretty well. On the flats, it gets moving pretty fast, like 20, 25 miles an hour with like 10 seconds of full throttle.
Hey, congrats on that, man.
Yeah,
That's
thank
awesome.
you. Appreciate it. Yeah, so I got all my battery stats and stuff right here. 7 or 8 house outlets worth of power. Yeah.
Do you have to always keep your arms in that position?
Yeah, so they're clipped to a climbing harness,
okay.
kind of stay loose, and the force goes into my hips. Yeah.
Perfect, dude.
Yeah.
Oh, really cool.
That is so cool.
Really good.
My friend's been filming me all day, so it's only fair that he also gets a turn with this. He also weighs 40 pounds less than me, which is about a 20% increase in power to weight ratio. So let's see, how fast does this get him going?
Dude, this thing is crazy. This is crazy.
Yeah, so the power to weight makes a huge difference. With me, it was a slow buildup of acceleration where he just takes off like a rocket, like insanely fast. Well, this brings us full circle and back to the intro where someone wiped out. Now, I gotta say, the conditions were nowhere near perfect, and that battery is really heavy and easily throws you off balance. Crash footage is always good content, so obviously I'm gonna include it.
Whoa! I'm good. That's so heavy.
The important thing, no one was hurt. We went over safety information beforehand and we followed it to a T, which is great. Here, I'm gonna kill the battery.
Oh, yeah. Just burst it to make sure it's off as a safety check. Yep, cool.
It's not terrifying.
then once I really let it go full, I was like, oh, this is kind of terrifying. It's real fun just to like zip around on a flat.
It was so fun to zip around on this and to talk to people and inspire them to make stuff, but at some point I have to end the video, so I'll stop showing you clips and we'll go over the last thing, which is, can my friend make it uphill? Which the answer is a definitive yes. Ski Patrol wasn't super happy about it though.
He's not skiing with that, is he?
Huh?
He's not skiing with that.
We're done for the day.
I'm not sure we want people skiing with that.
Okay, that's fair.
Yeah.
Well, with that, let's head back and go over the last few things and wrap the video up.
So I looked up the rules beforehand, and at least for the mountain we were on, there wasn't anything specifically saying I couldn't use jet skis. There was a rule about no powered uphill travel. Obviously, this was intended to prevent snowmobiles from going uphill, but that means technically, I could use this project to go downhill really fast, or to get over to untouched powder. I guess that means the one time Ski Patrol did tell us to stop at the end, we were kind of breaking the rule though, so oops. Besides that, let's talk about the broken EDF. Like I said earlier, it was really stupid. After I got back from filming, I showed another maker friend that doesn't ski how the project worked. To be honest, it happened way too fast to really see what happened. My best guess is that a bolt holding down the voltage converter loosened up and was able to slip out and get sucked into the EDF. I neglected to use Loctite on the project, mistake on my part, and between the vibrations, the temperature swings, and the voltage regulator having these like open-ended wings to bolt it down, I think that's what happened. I didn't have a camera rolling, but oh boy was it glorious. 1 second it was there, and the next second, the room we were in was just filled with little plastic shards and a few big pieces. Thankfully, no one got hurt, but in the future, every nut and bolt is getting a big old dollop of Loctite, and the voltage regulator is getting a little 3D printed shoe so that the bolt can't come out unless it fully backs out of the T-nut. Good news though, I already repaired the motor, so if you're watching this and you're with Red Bull or some crazy ski channel, and you want to try this for yourself, well, reach out, we can sign a bunch of waivers and maybe set some new ski speed record or something. Lastly, I want to thank you for watching until the end. Making projects like this is a lot of fun, but the most rewarding part is being able to show people the project and inspire them to make something themselves. Before starting this project, I had never worked with EDFs, or RC flight control parts, nor have I ever spot welded a battery before. Obviously, I did a lot of research going into a project like this, but I want to make it clear that you don't have to know how to do a project to do a project. You learn from research, you overcome challenges, and eventually, if you stick with it, you succeed with the build. I hope I inspired you, or someone you share this video with, to go out and make something cool, and then they can share that with the next person and so on and so forth. Speaking of, and not to draw this video on for too much longer, I'm trying to build a virtual maker community. I have a link in the video description to a website, probably like methodicalmaker.com. It's pretty bare bones right now, but eventually it'll have merch and other things on there. Now it's going to have a link to a Discord server on the website. It's free to join, but I also plan on having a tier that puts you in like a paid members only channel where you can ask for help on projects when you hit a wall and need some outside perspective on how to overcome the problem you're facing. The general Discord will also be focused on collaborative problem solving, but the members only channel will be there just as a way to make sure that the people supporting the channel directly are being seen and not overshadowed by a torrent of general chat messages. I always hated typing a long in-depth message only for it to be pushed off the screen before it's replied to. I want to try to minimize that in my own community. Anyway, I've been rambling enough. Thanks for watching, and I'll see you next time. After all, you did just watch 30 minutes of this, so you probably are subscribed. All right, bye.